Perhaps the most dangerous and volatile substance known to humanity is antimatter. Combine it with matter and it will annihilate, releasing a tremendous amount of energy. And scientists not only know how to make antimatter, they're trying to collect it and transport it around the globe. Sounds dangerous, but is it? Let's take a look. Studying the properties of antimatter is a great way to understand some of the most basic laws of nature. Scientists have already developed techniques to study individual matter particles like protons and electrons, and the hope is that we can do the same thing with their antimatter counterparts. If precision tests reveal differences between matter and antimatter, it would be a really big deal. The problem is that the locations that have the most sensitive test equipment are not always the places where antimatter is made. So scientists at CERN, which is our sister laboratory in Europe, are developing magnetic containment units that will allow scientists to trap antimatter protons and transport them to locations that house the sensitive testing equipment. So that means that it may be that in the near future, scientists will be shipping antimatter. And given that I told you that antimatter is dangerous, you might have questions. I would. Okay, so let's start with the answer. No, there is no credible danger. However, given what I've said, I owe you an explanation. After all, there is an awful lot of energy stored in antimatter. If enough antimatter touches ordinary matter, you have a ginormous kablooey. It all boils down to Einstein's equation, E equals mc squared, and really the troublemaker is that c squared number. C is the speed of light, which is 3 times 10 to the 8 meters per second. Square that, and you have 9 times 10 to the 16. That's a humongous number. Ballpark, that's 100 quadrillion. Take a gram of antimatter and a gram of matter, so 2 total grams or 0.002 kilograms, multiply by that c squared number, and we're talking a staggering 1.8 times 10 to the 14 joules. A joule is a measure of energy, and it's not very much. 1 joule can increase the temperature of a gram of water by 1/4 degree Celsius or 1/2 degree Fahrenheit. But 1.8 times 10 to the 14 joules is a whole lot of joules. The combined energy release of the atom bombs that ended World War II was 1.4 times 10 to the 14th joules, which is, round numbers, the same energy release as would occur if you mixed a gram of matter and antimatter. So this sounds all scary and all. It sounds even scarier because antimatter isn't just some science fiction thing, it's quite real. Now, as it happens, the CERN antimatter production facility makes just tiny amounts of antimatter protons, less than a firecracker's worth. But, just for fun, let's run the numbers for the biggest antimatter production facility that was ever built. This facility made much more antimatter than the CERN one does. Indeed, from 1985 to 2011, Fermilab operated the most powerful antimatter production factory on the planet. Towards the end, our scientists were producing about 250 billion antiprotons per hour. That's 250 billion. Now, 250 billion is a big number if you're talking a paycheck, but it's not nearly as big a deal when you're talking about atoms. The fact is that numbers can be deceiving. A gram of antimatter requires something like 6 times 10 to the 23 antiprotons. If the Fermilab facility ran 24 hours a day, without stopping, it would take 280 million years to make a gram of antimatter, which is an awfully long time. 280 million years ago was before dinosaurs even appeared. If you added up all of the antiprotons ever made at Fermilab, the whole shebang adds up to something like 10 to the 16 antiprotons, or about 20 nanograms worth. The total energy that would be released if you annihilated 20 nanograms of antimatter with matter is appreciable, but let's give it some real context. If you had that much energy, you could warm a cubic meter of coffee from room temperature up to something drinkable. A cubic meter is a lot, to be sure, but I've been in meetings where it seemed like I've needed nearly that much to stay awake. I'll bet you've been in similar meetings. Am I right? All right, if you don't like the coffee analogy, That much energy would warm enough water to have a relaxing bath. The bubbles would, well, be your responsibility. So this is the real bottom line. If someone were actually able to make a gram of antimatter, this would be a cause for concern. But antimatter is really, really hard to make. 30 years of effort by world experts made enough to fill a cube that is about 1/3 of a millimeter on a side. And even today, if we used modern accelerators and built a specialized production facility, it would still take something like 1,000,000 years to make a single gram. Antimatter is one of those things that sound made up, but it's real, and it provides a fascinating laboratory to better understand the laws of nature. Given how difficult it is to make, it's entirely safe, and I'm looking forward to hearing what lessons it has to teach us. So that was kind of cool. Antimatter sounds like one of those made-up sci-fi things like lightsabers and warp drive. But antimatter is entirely real, and as it happens, entirely safe. If you liked hearing about antimatter, please hit the like button and subscribe to the channel.